This is a very good example of a Fourier transform problem where the signal xt is given and we are asked to compute its Fourier transform. You can solve this example using the Fourier transform integral directly, but that process may involve difficult integrations. Instead, in this video, we solve it using a much more elegant and intuitive method that I think you will find very interesting. First, let's rewrite the signal. Since the problem states that the signal exists only in the interval between -1 and 1, we can represent the signal schematically as 1 plus cosine of pt multiplied by a rectangular pulse that is equal to 1 between -1 and 1 and 0 elsewhere. So we can rewrite xt in this form. Now let's recall an important signal. Suppose we have a rectangular pulse that is equal to 1 between minus t1 and t1 and 0 elsewhere. We denote this signal as pulse of t over 2t1. Its Fourier transform is 2 sine omega divided by omega. We will use this result to solve the problem. Since in our example t1 equals 1, we can write the rectangular pulse as pulse of t over 2. So the signal becomes xt equals pulse of t over 2 plus cosine pt multiplied by pulse of t over 2. Now let's use Euler formula. Recall that cosine theta equals 1/2 e to the power of j theta plus 1/2 e to the power of minus j theta. Since theta equals pt, we can rewrite the signal as pulse of t over 2 plus 1/2 e to the power of j pt multiplied by pulse of t over 2 plus 1/2 e to the power of minus jpt multiplied by pulse of t over 2. Now we use another important Fourier transform property. If xt transforms to xj omega, then e to the power of j omega 0 t multiplied by xt transforms to x of j omega minus omega 0. This is called the frequency shifting property. Now we can compute the Fourier transform easily. Let the Fourier transform of the pulse be xj omega. Since t1 equals 1, the Fourier transform of the pulse becomes 2 sine omega divided by omega. Now we apply the frequency shifting property. For the term 1/2 e to the power of jpt multiplied by pulse, the frequency shift is omega 0 equals p. So its Fourier transform becomes one half multiplied by 2 sine of omega minus p divided by omega minus p. Similarly, for 1/2 e to the power of minus jpt multiplied by pulse, the frequency shift is minus p. So the Fourier transform becomes 1/2 multiplied by 2 sine of omega plus p divided by omega plus p. Putting everything together, the final Fourier transform is x of j omega equals 2 sine omega over omega plus 1/2 2 sine of omega minus p over omega minus p plus 1/2 2 sine of omega plus p over omega plus p. So in this example, instead of solving difficult integrals, we used signal decomposition, Euler formula, and the frequency shifting property to compute the Fourier transform easily. If you found this example helpful, please subscribe to the channel and like the video.